My newest project for 2014 is the SDS WiPars. These lights are each a different color, and each have 8 LED watts of white LEDs to lighten the colors. The original design was a wired set of lights and a main controller, but running wires from the controller to the units in a real-world environment can be cumbersome and difficult, not to mention the multi-conductor wire would need to be long, which could limit where the lights could be positioned relative to each other. If each light had its own power supply and could be linked to the controller wirelessly, the lights could be positioned anywhere as long as there's somewhere to plug it in. It didn't take long to figure out that using a 2.4 GHz transceiver was the only way to go. They're a tiny module with a range of any wireless, which is more than enough for this application. The interface is via SPI, using the standard pins, but with an IRQ output, which is handy. Because I like to reuse and recycle, deciding to make the cans from empty plastic tobacco tubs is nothing unusual around here. But with the new design and built-in power supplies, taller tubs had to be used. The raw LEDs have been sandwiched between 2 pieces of aluminum plate spun out on the lathe, with holes drilled to hold 16 3-watt color LEDs and 8 whites. Little fans attached to the backs provide some airflow. I should have used bigger fans, but these are all I have, so for now they're staying. LEDs can be pretty blinding, so I spun some old plexiglass on the lathe to make a disperser. It cuts down on the sharpness without lowering the output level. A clamp-on bracket made from aluminum and a large plastic clamp will be added to each unit. This will allow easy mounting to just about anything. The power supplies, originally encased in plastic, are 72 watts at 24 volts. 2 of the lights need about 30 volts, so these were modified to do the job. The first board has been hand-drawn and didn't require much modification to get the first light up and running. As you can see, it's pretty bright. It's so bright I had a bit of a time getting a decent picture. These cans can also run in standalone mode without the controller. Got some serious heat going here. Let there be light. Now soon the fan will kick in because it's heating up, hopefully. Blinded. It's pretty bright, you can see. Don't think I'd ever use it this bright for long periods of time. And you can see the board. There's the fan. It's going. And the dimmer. I can dim it right down. And if I select for the white one, I can dim it down to nothing. So we'll select the green again. And here it is. Pretty amazing. Oh, shine it in there. Here, look at me, how lit up I am. My retinas are burning. Inside the backplate there's a pot for dimming, but because the PIC 16F57 doesn't have built-in ADCs, I had to use the resistor capacitor method. This was also used on the thermistor mounted to the aluminum plate to detect when to turn on the fan and when the auto dim is needed if the fan fails. You can see the time constant differences here. It was a bit tricky getting the right components as this little chip has a lot of other things to do at the same time. The controller case, quite different from the one I drew here, is being fabricated from an old satellite mixer and some tinted plexiglass my neighbor gave me. The buttons are from a big telephone, easy to see in a dark room. They've been custom labeled, of course. I had to make those Flintstones like slider knobs because I just don't have any. The back panel has sockets for antenna, power, auxiliary, and MIDI in-out for the computer control. Also, there's a mic gain for synchronizing with music that's playing. So that's about it so far. The next video will have the finished lights all working, I hope. You can follow my progress on www.freshnelly.com/sdswiPar.htm. Bye!